Okay, so I'm going to try to record without having the camera on to see if it's a little bit less laggy. I don't know though. Okay, so here, the interesting thing about this problem is omega is going to be the first quadrant, and then the curve on which we know u is going to be like the y-axis and the x-axis. Okay, so the omega, the domain, is going to be the first quadrant, and the boundary of that, the curve on which we know u is going to be the positive y-axis and the positive x-axis. Okay. Okay, so that is the or the y-axis. This one is the x-axis. Let me get rid of that mark. Okay. And so now we're going to see something interesting happen when we start working on this. So x dot of s is going to be equal to 1. But now what is x of 0 going to be? Okay, so there's going to be something interesting going on here. We'll deal with that in just a moment. Y dot of s is going to be equal to 2. And if I look at z of s, z dot of s, well, again, this part is always z dot. So, if I move everything over, this is partial xu plus 2 partial yu is equal to u. So then z dot of s is just equal to z of s. And z of s is always going to be u of x naught y naught. Which in this case is going to be 1 plus x naught. Okay, so notice that if I solve this system, so I'm just going to write this. We'll figure out what x of 0 and y of 0 should be, but for now I'm just going to write x naught and y naught. Okay, and again, this is a very simple system of equations to solve. It tells me x of s is equal to s plus x naught, and y of s is equal to 2s plus y naught. Okay, but notice if my curve starts here, so the slope is always going to be 2. If my curve starts here, then the initial value, x is going to be equal to 0, and y is going to be equal to y naught. Whereas if I start here, again, the slope is still going to be 2. Whereas if I start here, x is going to be just some generic point x naught, and y is going to be equal to 0. Okay, so I'm going to kind of have different the initial values are going to be different depending on what characteristic I'm looking at, and what characteristic I'm looking at is going to depend on what point I'm looking at. So if I'm looking at this generic point A and B, I'm going to want x naught to be just whatever this happens to be, and y naught will be equal to 0. On the other hand, if I'm looking at this generic point A, B here, y naught will be the arbitrary value, and x naught will be equal to 0. So I'm going to kind of separate this. We're going to separate the plane into two different regions. Okay. Trying to draw a straight line. Okay, and I'm going to basically solve two problems and then put the solution together. Okay, so let me just draw a straight line here. Okay, now the first thing is I notice that there's this sort of dividing line that happens at 0, 0. So if I look at 0, 0, where x naught is 0 and y naught is equal to 0, so it's basically going to be something like this. Whoops. Okay, so this is kind of the dividing line. Not kind of, this is the dividing line. And what I mean by that is if I have a generic point above the green line, if I have a generic point that starts above the green line, its characteristic is going to be traced back to the y-axis. If I have a generic point that starts below this green line, its characteristic is going to get traced back to the x-axis. Okay, and so let's see how we can actually use this to help us solve the differential equation. So first of all, z dot of s is equal to z of s. So if I solve this equation, this tells me that z of s is going to be equal to 1 plus x naught, that's z of 0, times e to the s. Okay, so in other words, if I'm going to do the top part first. We're going to break this into two regions. I'm going to call this region 1, and I'm going to call this region 2. Okay, if I look at region 1, if I look at what's happening in region 1, I'm going to trace my characteristic back to the y-axis. Notice x naught is equal to 0, and what this is saying is that if I just look at the PDE along this line right here, z of s is going to be equal to 1 plus x naught e to the s, or just e to the s. So along this line, the solution is equal to e to the s. So u of ab, so again for the blue point in region 1, so the blue stuff is going to be in region 1, u of ab is equal to 1 plus x naught, so x naught is just equal to 0, so it's going to be e to the s. So u of ab is equal to e to the s. Okay, well again, I need to figure out what s is in terms of a and b. Well, if I solve my characteristic equations, well, I didn't put the solutions, oh, I did right here, yeah. So SA, if I'm in region 1, x naught is equal to 0, so then A is just equal to S, and B is equal to 2S, 2S plus Y naught. So S is equal to A, so this is just equal to e to the A. So in region 1, U of xy is just equal to e to the x. Okay, u of xy is just equal to e to the x. All right, so now I'm going to see what happens in region 2. So now I want to see what happens in region 2. Okay, so in region 2, again, if I'm on my this is my generic point in region 2, if I just look at the PDE along this line right here, z of s is equal to 1 plus x naught e to the s. So if I just look at u along this line right here, and I know how, I can figure out what I can figure out what u is at ab. U of ab is equal to 1 plus x naught e to the s. But again, I need to figure out what x naught and s are in terms of a and b. Well, again, I'm going to solve my systems of equations. So in this problem, in region 2, a is equal to s plus x naught. And b, well, y naught is equal to 0, so b is just equal to 2s. Okay, so then u of ab, okay, s is equal to b over 2. So x naught is equal to a minus b over 2. So this is 1 plus a minus b over 2. And then s is equal to e to the b over 2. And again, changing to x and y, u of xy is equal to 1 plus x minus y over 2 times e to the y over 2. Okay, so now I'm actually going to make this black line a little bit shorter. Okay, so this is sort of how we want to write the solution now. So I know that in region 1, u of xy is equal to e to the x. In region 2, u of xy is equal to 1 plus x minus y over 2. Okay, so what happens on the line y is equal to 2x? What if y is equal to 2x? Well, notice that if y is equal to 2x, so basically both of these formulas should work if y is equal to 2x. If I look in this equation and plug in y is equal to 2x, notice x minus 2x over 2, this part would be equal to 0, and y is equal to 2x, and this becomes what it needs to be. So if I plug in x is equal to x and y is equal to 2x, you can see that this here will become just e to the x. I'll let you verify that on your own. But think about what I'm saying here. The green line, we're kind of dividing the plane into two regions, above the green line, below the green line. If things are going to work out the way that we think they should work out, and they're not always going to work out the way that we think that they should work out, but if things are going to work out the way that we want them to work out, the formula in region 1 should work for the green line, and the formula for region 2 should work for the green line. And what I'm saying is, if you come over here in the region 2 formula and plug in y is equal to 2x, in other words, you're just along the green line right here, you're going to get this solution here, e to the x. Okay, so then u of xy, so I want to write this as a piecewise function, not like this region 1 and region 2 stuff. Now, it's not always bad to write things in terms of region 1 and region 2, but if we can kind of do things algebraically as well, it just makes things a little bit better. So it's going to be e to the x when you're in region 1, but in terms of inequalities, this is going to be when y is greater than or equal to 2x, and then it's going to be 1 it's going to be 1 plus x minus y over 2 times e to the y over 2 when when y is less than 2x. Okay, so this is the solution. We have to write it in this piecewise way, but there it is. That's the solution. And again, so this sort of cool thing or interesting feature going on here is that we have different x naught and y naughts depending on, if I look at a generic point here and I trace the characteristic back until it crosses through my Cauchy curve, which in this case is the positive x and y axis, I'm going to get a different x naught and y naught depending on where it crosses. I'm always going to get that, but I can't kind of have a generic formula there like I had in previous problems.